being recorded, I believe. I'm giving you kind of a notice that I am recording it. So from now on, until I stop the recording, what we're saying and doing is being recorded, and I do intend to post it to YouTube, which is a public thing. So just prepare yourself for that. I want to first go be in awe. I was so amazed with your first amount of work that you're doing. You have all stepped it up. I saw some amazing code being submitted with decent handwriting, cameras took great pictures. People carefully submitted their code. And I went through everyone's work this weekend with a huge smile on my face, realizing this class is going to do well because you are willing to put in the time and energy it takes to learn a new language. When people ask me, what is the best or what's the most effective way to learn a new language? What's the best thing to do? The answer is the best way to learn anything is to practice. So the best way to get better at coding is to code. By the way, that's also the best way to get better at reading. The best way to get better at reading is to read. It's the best way to get better at math. The best way to get better at math is to practice math. It's also true of video games. The best way to get better at Overwatch is to play Overwatch. So in whatever you want to do in your life, the best way to get better at it is to keep practicing it. And there is this 10,000 rule out there now where they talk about in order to become an expert at anything, if you do it for 10,000 hours, you will become an expert at it. So you're not going to reach 10,000 hours this year, but this is the start of your journey at becoming an expert in computer science by practicing coding. And the more you do it, the better you'll get. Look at this beautiful code submitted. Now, I am going to show you all the errors I found, and I'm not going to show every person's error. The errors were in patterns. So this one looked pretty good. You can see this one is an example. This is not the only person who did this. If you recognize your work, don't be like, oh, I'm the one who screwed up. No, this is a good example of people who would lose points on the exam, on the quiz we're taking probably Thursday, because of capitalization. Did they capitalize their P or not? Did they capitalize their S or not? It's hard to tell. So if I can't tell, it's wrong. You have to be obvious about your capitalization in this exam. The P's in this particular case, look at the P. I like this example because look at the P in public and the P in practice on the first line. The first line, the P in public should be lowercase. The P in practice should be capitalized. Lowercase public, capital the class, because the name of a class is capitalized. Yet in the word print, for print line, it should be lower. And the S, by the way, in string and the S in system should be capitalized, but the S in static should be lowercase. Does the capitalization in lowercase of letters matter? In Java, it does. Some of it's only style, like the P in practice is actually a style decision. As Java coders, we have just all agreed that we are going to capitalize the name of classes. String is a class, thus we capitalize it. The system.out.println, that system refers to the system class, and those are dot operators on the system class. That's why we capitalize it. Here is another really good one that made a mistake a lot of people made. I call it the semicolon mistake. And there were lots of semicolon mistakes, but I like this one because it made both of them in one. So look at the public static void practice line. Look at the beautiful capitalization, by the way, and the neat handwriting. I love the curly braces on this one. They're perfect. But look at the end of the public static void practice line. There's a semicolon there. You should have a semicolon or a curly brace, with the exception of very few cases. One of them is a switch statement, but very few cases. So that semicolon is an error. However, that same semicolon, if it would just drop down to system.out.println, high would be perfect. So notice the extra semicolon and the missing semicolon. A lot of people had extra semicolons. I saw a lot of them on the first line and the third line. And I did see people miss it on that fifth line. So just be aware of that. That happens, and try to get that straightened out. I think this is, I wrapped with a perfect one. I also like that this person was putting down dates and organized. I think I ended to remind me with a perfect one. That looks really good. I don't see any mistakes. All right, we are going to skip this for time. I thought I took all these out. I did change things a little bit because we only have an hour. So sorry about that. I did attendance already, and we're not going to do that today. I do want to quickly review the difference between print line and print. Print line does a carriage return, where after it's done with that line of text, whatever you put between the string literal, the quotation marks, when it's done with that, it's going to automatically start a new line for you. The system.out.print is useful because it stops the cursor. Think of it like a word processor, and it stops the cursor right where it leaves off. It doesn't hit that enter. It doesn't do that carriage return. We also have those escape characters. Remember that backslash right above the enter key? If you go backslash, backslash, it prints a backslash. If you go backslash quotation mark, it prints a quotation mark. If you go backslash n, it starts a new line, kind of like hinting the enter line, hinting the enter button or the carriage return. And backslash t makes a tab or 5 spaces. The forward slash, those are comments. So if you go 2 forward slashes, you will get a comment where the compiler will ignore it, but humans can read it. And if you go backslash star, you'll get a multi-line comment. You'll see both of those used today by me when I give you some programming challenges for homework tonight. So those are coming up. I want to start with, please excuse my dear Aunt Sally. Order of operations, a classic, right? You've all done order of operations. You're all familiar with order of operations. Oops. Sorry about that. I forgot to activate GoGuardian. Just 1 second. I got to turn that thing on. Here we go. Okay. Order of operations is the exact same as it was in algebra. So all the previous knowledge you've obtained from algebra class applies to this computer science class. The thing that is different, or a critical difference, it is that when you put those parentheses in like a 3 and then parentheses and then 7, if you were to do that, it wouldn't take 3 times 7. It would be confused. You'd have to go 3 and then the times symbol for the asterisk. But other than that, it works pretty well. The other thing I really like about Java order of operations that I couldn't do when I was in math class, another reason math class is just that much better than computer science classes. Love to pick on the math department. Sorry about that. If you want to, you can just throw in extra parentheses, and it's encouraged. So if you're afraid people will be confused what you want to do first, even if the order of operations tells you what to do first, just throw down some parentheses so that people know that that's going to be done first. It just makes it easier. So if you're going 3 plus 2 times 7, order of operations tells you that the 2 times 7 is going to come first, 14, then plus the 3. But if you throw down parentheses, it just makes it clear. And why not do that? It's just some vocabulary. That num gets, or that num equals, it's with the equal sign, but we say gets to keep it clear. That's called the assignment. And the expression is the thing after the equal sign, which is the assignment operator. The expression is solved first, and then it's poured into the variable. So it's not like left to right math completely. Whatever is after the assignment operator, in Java, that's the equal sign, that is solved first. So the value of num at the time of running, at the time of that line, is what you're going to get first. So if num got 7, gets 7, and I say num times 3, it's 21, and num is now reassigned. It doesn't go into this crazy like recursive thing. And I think most of you are experienced with that from JavaScript in APCSP. Math operators work exactly like you'd expect them to. Plus, minus, times is that above the 8, and division is that slash that's right next to your shift key. Just like last year, just like in JavaScript. But there's a couple of new things that I'm now going to throw at you that's confusing, and we're going to take some time with this. There's integer math, and there's double math or decimal math. When you divide an int by an int, the answer will be a int. For example, if you take 10 and divide it by 20, if you do that on your calculator, you will get 0.5, right? In integer math, since we are in integer mode and both numbers are integers, we are in integer mode. When we're in that integer mode, we are going to do integer math, and 10 divided by 20 is actually 0. Freaky, I know, but true. And it has a remainder of 10, but it is 0, remainder 10. And the answer of that operation is a 0. However, when you do double, when it's double math, when you're going 10 divided by 20, and you're putting it into a double, you will get the expected results like a calculator, and it would be 0.5. The term we use for that process, you could call it truncation. Well, they'd call it truncation, sorry. That's when there is no rounding in integer math. You just get the answer and you drop. So that 0.5, it's just dropped and moved to 0. So, and the results, the remainder, I should say, in integer calculation go into the what we call modulus operator. Modulus is big in Java. You are going to use it all the time, and I beg you to start to get familiar with it, and we're going to spend some time with it. In APCSP, I introduce it, but we really don't go very far with it. In Java, we're going to spend a lot of today on our friend, the modulus operator. The modulus operator is the symbol for it is that percent sign. That's the modulus operator. Just like the times operator is the shift 8 or asterisk, the modulus operator is the shift 5 or percent sign. And that means give me the remainder of integer division, which comes in very handy. We're going to see 2 very good uses for it in today's assignment. Maybe homework, maybe assignment time. We'll see how long it takes. Let me show this in like 4th grade math. If you were to make a class that, or if you were to assign a variable that the divisor of 5, the dividend of 137, and you were in like 4th grade, you probably drew something that looked like that, where you put the 137 behind that little bracket thing and you had the 5, and then you solved, and you've got an answer. It was called the quotient and the remainder. And right now, if you do the dividing in line 6 with the system out, you will get the quotient. If you do the modulus operator, you will get the remainder. So that's the way that works. It's tricky. Something I encourage people to think about for modulus is to think inside out. A common popular movie. It's a really good movie if you haven't seen it. You solve the problem inside out. You kind of have to switch the order of things, which is a little tricky for the mind because you're going to see things formatted like 16 divided by 3 or 16 modulus 3. And you have to put the numbers in the opposite order. You have to flip them inside out. And you have to put the 3 on the outside. Then you got to draw the bracket. You got to put the 16 inside that bracket when you're thinking about it mentally, if that's the way you think about division. I know that's the way I think about division. So you kind of have to do that flippy thing. And in order to find modulus, you have to do the work. You first have to do the division, then you get the answer. So it's a pain. I know. I have developed an app to help you practice this. I want to talk about the app before we actually play the app. So the first thing I want to talk about with the app is that notice that it's doing integer math. So if you see a problem like 25, x equals 25, y equals 10, the answer, which is going to go in that light purple box between the what is and the enter button, you're going to type in the number 2 and then hit enter. 2.5 is not correct because it's integer math. If we were doing double math, that would be correct. And by the way, JavaScript isn't a type-specific language, so I had to do a bunch of computer voodoo to make it work. Oh, I'm so glad Java is a type-specific language so that it works. But there's ways to trick it and to cast it, which is actually going to be a lesson I think we have on Wednesday. We'll talk about casting numbers into different forms, but or casting variables into different forms. The next one, when you look at 15 divided by 30, again, it's 0. So just be aware of that. That third one is kind of obvious. A little bit of work with modulus. When you do modulus, you have to solve the problem first. So you solve the problem, it goes in one time with 15 remaining. 1 is the divisor, but it's not the answer because notice how it's a modulus problem. Again, just continuing that pattern, just be careful. I do have a practice for you all, and I did launch GoGuardian so I can get to it, so I can share it all with you easily. It's going to look like this. You can launch it from the thing if you want, the slide deck if you want, but I can open it all for you through GoGuardian. I'm also going to put it into the chat. And I'm just going to give you some time that I will edit out of the video to just work on that. So I'm just going to save some bandwidth. And I'm going to set a timer for 5 minutes. And I'm going to ask you to just practice working on modulus math on your own. Hopefully it opened a tab for you and you're able to play the game. Is it working okay? Time is up. Sorry to disrupt your game. It is kind of a fun game, right? If you are really good at this modulus stuff, feel free to just pay attention. If you need more practice, bookmark that page. Go up to the top of your URL and hit the star button. And this is a great way just to put your mind into modulus mode. I myself have been playing it just for fun, just to get my mind into modulus mode. The division itself is purposely designed not to be challenging, but it just kind of gets my brain in the modulus mode, and it's kind of tough. Or at least it was for me. I shouldn't say everyone's going to have a hard time, but I really had a hard time grasping modulus because I constantly get which numbers I'm using backwards. And I'd often have to, a common bug I'd have would be to just flip the numbers and then, oh, now it works. So I'd flip which one was in which order with the modulus operator. Yet when dividing, I didn't have a problem. But when doing modulus, I'd get it wrong. So just kind of a great tool to use just to get better at that modulus operator, which you will definitely see on the exam, which you will definitely utilize throughout your programming. A really cool, I'm going to call it modulus rule, is that if the number after the modulus is greater than the number before is always the answer. So whenever you see something smaller, modulus something bigger, you know that first number is going to be your remainder, because the divisor is going to be 0 and your remainder is going to be what's ever left over. Another really cool use of modulus that we're not seeing in the sample problems is for rotating an object on the screen and doing that, like where Pac-Man's on one side of the screen and then comes back to the other side of the screen. That classic, like looping around. Any operation where numbers loop around like that is modulus. Because if you set the maximum screen size, like 640, let's just say your screen is 640 pixels across, you can set the X position to be the modulus of the current position modulus the resolution 640, and then just keep increasing the position by 1. Once the position gets to 641, the modulus of that is going to be back to 1. 642 is 2, 643, 3. And you can just keep wrapping around and you can count those numbers forever. And it just so happens that integers also wrap around. You saw that last year with the overflow error when it just wraps around. So the numbers keep wrapping around. So in other words, your sprite will keep wrapping around forever with the modulus operator, and you won't have to reset it. You can just use the modulus, and it makes it clean to make some pixels appear on one side of the screen, some pixels appear on the other, without that messy need for a partial reset of each line or whatever. So it's a really cool, useful, that's one useful modulus thing. There are many others, and you'll see 2 of them today. You can also do multimodulus. Multimodulus, holy smokes, Batman, is pretty darn cool. So just like you can do multiple operations, like using order of operations, you can modulus and division are on the same level of the please excuse my dear Aunt Sally, or order of operations. So I would start by going 40 divided by 45, which since 45 is bigger, it's 40. 40 divided by 5 is then 8. And I just went in order from left to right. Now, there were no parentheses. If there were parentheses there, it would have changed everything, but there weren't. Also for BB, we'd start with 20 divided by 3, which is 6 with a remainder of 2. So my answer is the remainder of 2. And then 2 modulus 3, since the 3 is bigger, the 2 remains. So that answer would be 2. So you can do multiple operations and multiple moduluses. This is a hint for one of your practice problems today. There is a one-step solution. You can also define a temp variable and break it into steps, which is what most of you will probably do if you're able to even solve that. It's a really hard one. But you can also do multi-modulus or multi-division and modulus, which would be the actual solution as a division step and a modulus step. But it can be done. It just goes left to right, or throw in parentheses if you want. Something cool, the scanner. I'm going to introduce you to something that I'm not going to fully explain yet today, but you need this for the class, but it's not on the AP exam. So this is one of those freaky things that I'm teaching a lot about. Marquette uses it, UW-Madison uses it. Most schools that teach computer science use the scanner to get user input into the computer. There are other ways to get user input into the computer, but we are going to use the easiest, most common one, and that's called the scanner. The scanner is a library that you add to Java that allows you to get user input from a variety of sources. You can get it, in our case today, we're going to get it from the keyboard. You can also get it from other files. You can get it from other input devices like a mouse, a joystick, VR gear. But the scanner just provides input into your program and has some syntax that you do not need to memorize for the AP exam. You just need to know how it works. The first thing you have to know about the scanner is that it is not default to Java. You have to import it. I'm going to do a very brief demo of the scanner class just so you can see how it works. And I got some feedback last year that people enjoyed watching me code. Not like, I should say that differently. Some people wanted to make sure I actually knew how to code. So they liked that every once in a while I would code. And last year I did it very little. We tried a different program that absolutely didn't work. Pandemic didn't help, but I did very little coding. And a lot of the feedback I got was like, could you show us coding more? So I'm going to make sure I do that. And today is a definite example. I'm going to make a new replit just as a demo. It's going to be in Java. I'm going to call it Demo Scanner. And here is my demo scanner that you're watching me code. This is the default. Isn't it nice that it loads the boilerplate code? This code here is the imports that you will never have to memorize. In fact, in most programming languages, or most IDEs, integrated development environments you'll use, as soon as you use one of the commands from a common library, it will automatically ask you if you want to import it. And like IntelliJ, for example, automatically just puts it in there. You don't even have to think about it. As soon as I type in the scanner commands, all of a sudden the scanner will open. Also, I will always provide you the scanner code. The scanner code looks like this. Scanner in equals new scanner. That is always going to be provided to you, so you won't have to worry about it. What that's doing is that's giving me a new scanner object. And for now, it's just going to be provided to you. What's really cool though, is I can do a system.out and I'm going to make it a print and I'm going to say, what is your name? And then I'm going to do one of these little prompty things. Notice I use print instead of print line, so that right next to it, I'm going to have an opportunity to provide input. And the way I'm going to provide input is I'm going to ask for a string. I'm going to name that string name, how original, and I'm going to set that to in, which is the object, and I'm just going to say next line, which is just the computer's way of getting all the information on that line. Then instead of hello world, I'm now going to print hello name. Let's see how this sloppy code, sorry about my poor style, ooh, drives me a little batty. There, that's fixed, right? All right, let's run that and see how many errors I made. You know I'm going to have errors. Rody, where did I mess that up? New scanner system.in, sorry. I got to tell it where to get the source. My bad, that was my bad. Let's see whatever other errors I made. What? Only one? I should have made some on purpose, sorry about that. Okay, it is now asking me, what is my name? And I wish I could make this bigger. I was playing with it and I couldn't figure it out. If anyone can figure out how to make that bigger, that would be great. My name is Mr. Rody. Hello, Rody, look at that. Now, what's also cool is I can have it input numbers too. I'm going to use this symbol for input. And I'm going to change it to a print so it's on the same line. And then I'm going to take in an int this time. Int year equals in next int. Ooh, did you see that? It kind of provided it. Next. Look at that. Ooh, what intelligent help. I love it. Next int. And then I'm also going to system out. You are old, born in. And I'm going to use the concatenation symbol, and I'm going to do the year. And here we go. Let's see how that works. What is your name? What is your birth year? You are old, born in 1971. I'm in a little bit of denial about that. So I'm going to subtract 10. Hopefully some of you are, nope. I'm going to add 10. That will cause the problem I want. Let's try that. Brody. 1971. Now it should say 1981, right? What? If I want it to do math, I got to put it in parentheses. So now let's see what it does. There, it did what I wanted to do. Wow, I feel better about that. I was born in 1981 when I was actually probably like in 4th grade. Okay, cool. All right. Back to this. Yep, we did that. Okay, now we got some fun. We're gonna do some fun things. I am going to beg you all to join my Gimp Kit classroom because I can give you Gimp Kit homework, which is kind of cool. So I'm going to send it a couple of ways. You can click on it in the slide deck. You can go to it in the Google Classroom. It's in the chat. And if you wouldn't mind, just for fun, joining right now my my Gimp Kit classroom. And then to kind of wrap up class, we are going to play a fun Gimp Kit modulus game. And then we're not going to play it the full 10 minutes. And then I'm going to wrap with your homework, which is 2 coding assignments. So feel free to sign into that Gimp Kit for fun. I'm going to get a Gimp Kit game ready here. All right, if you're willing, would you mind joining my Gimp Kit game when you're signed in? You don't have to be signed in as you. You can be anyone and join the Gimp Kit live. We're going to do this Gimp Kit live here. I'll put this in the chat window if it saves you a little bit of time maybe. But we're going to play 1 round of Gimp Kit, and just for fun. And while people are getting that all set up, looks good. The Gimp Kit code, if you're multitasking, is 47765. 47765. We are only going to play for 5 minutes, not our usual 10 minutes, just because the class is only 10 minutes long and I still have some homework to have you look at. And you won't have a code tracing today. And you won't have any writing or other things to do. You'll just have 2 coding assignments. And I'm hoping everyone's able to open them. I hope I did everything right on my end. We got 19 players. We have 23 people in the class. So, oh, we do have some absent. So, Merrick, how did you do that font? Cool. All right, I've got to start. You can join late. If you're struggling to get in, you can join late. Here we go.
Mr. Odie, you're muted. Mr. Odie, you're muted.
Oh, sorry. I congratulated Yvette, Jason, and Ethan in a muted mode. Thank you for the prompt. I will do that frequently, by the way. It's just the way I roll. I try to mute it when my computer's playing sound at the same time. It's sending sound through the computer because I hear it gets a little echoey, but sorry about that. I gave a great spiel too. I'm now going to talk about homework and then going to dismiss class. So about 5 minutes, hang in there. Right, what I'm going to ask you to do is practice a modular Gimp Kit. So hopefully in your Google Classroom, in classwork, there is now a link that says practice integer math. That is a Gimp Kit that, again, this is just to practice. It will be that same one, and it asks you to get to 100,000. I'm just curious if people find that to be useful and helpful. Feel free to try it. It's a total experiment. I'm not going to grade it, but I am just curious how that homework works with Gimp Kit. You're the first group I've ever given Gimp Kit homework to. So that's the Gimp Kit homework, especially if you're struggling with modulus. I do have 2 problems, though. I want you to apply coding, which is tough. And you might need to review the lecture. You might need to review the slide deck. And you have 2 problems I'm going to ask you to do. One is an odd problem. I think even some of you will be impressed with this one. Oh, my odd and even humor. It's pretty good today. And the last one is a really, really hard one called modulus math. I want to briefly show you what those problems look like and discuss them a little bit. They should be in your team projects if I did everything right. There's one called the odd scanner and one called modulus math. So when you go to the odd scanner, can I just click on it and go there? I have to click on edit. Oops, okay. When you load your odd scanner, you will be, one thing I encourage you to do is as soon as you get there, just run the thing and see what it's doing and what it's asking you to do. The way the program works is you're going to physically type in a number and it's going to show you the modulus. Well, right now it's showing 99. Well, that doesn't make any sense. The modulus is not 99. That's because you have to write the code. You have to fix that up. And then if you want to stop, the set no value of -1 will stop the program. -1 should stop the program. Modulus 2 can be used to do what? Oops, I accidentally programmed it, put it into the code there. So that is that first problem. The next problem is the very, very hard one. When you first open this project, what you will see is a kind of like a README file. Well, it's not kind of a README file. It's actually it is actually a README file. And it is telling you what you have to do. The way this program works is the user enters a number between 100 and 999, and you are going to use modulus math and division, modulus and division, to figure out the hundreds place, the tens place, and the ones place, and provide that. So when I type 1, 2, 3, it should say hundreds place 1, tens place 2, ones place 3. As you can see, it's not done yet, and it doesn't even get the answer right. So what you have to do is the README comes up by default. You have to click on the Java, and you have to write the code to get that to work. You also have to write the rest of the system.outs. I only wrote one of the system outs. You have to write the other system outs. Just in case you mess up the program, I'm going to put the code at the bottom of the README, just in case something bad happens, you can recover your code. There's the code. It should hopefully be there now. I'll put it in here too. Sometimes when you're editing it, you end up messing it up, and yeah, I'll make sure you have access to it in 2 places, just in case things go bad. It's also now in case code goes bad and you need to copy and paste it, it's also at the end of the slide deck. So that is your modulus math homework and your odd homework. That's all I've got for you today. You are dismissed. Please try to have those 2 pieces of code done by tomorrow. So you do have homework. Try to code that by tomorrow. See you tomorrow at 8 o'clock. Thanks, everyone. If anyone has any questions, feel free to stay on the line and I'll answer any questions. I'll stay online until everyone's questions are answered. I'll do my best to answer them.
Oh, what's the word on the Discord server?
Say that again.
The Discord server?
Oh, there is no word on the Discord server yet. I was going to get a hold of Nikolai, and yeah, we're going to work on that. Yeah. Nikolai is pretty serious about it. And he said he'd set it all up, but I was to get a hold of him and talk about some details. I didn't do that this weekend. Shoot. Yes. Won't that be cool?
Yeah.
I think so too.
I'm going to head out.
Great to see you, Katie. Anyone else with any questions, concerns, comments, random thoughts, good jokes?
I wanted to let you know that Nick actually has the Discord server technically set up.
Good.
He invited it to me right after class last week, so I guess if he's ready, we can start inviting people.
Yeah. What do you need to invite? Would it be helpful to like have just some class time and then invite people that way?
Probably, yeah.
I can also share the link on GoGuardian, and then we can put it in the chat window, and I can put it in the slide deck. So everyone
that would probably work.
Between those 3.
Do you want me to send you an invite to that server today?
Yeah. Would you mind?
Yeah, not a problem.
Awesome. Well, thank you, Connor.
Yep. That and I don't have a 2nd, 3rd, or 4th hour, so I don't have much else to do.
Oh my gosh. As long as I got you, can I ask you a question?
Yeah, go ahead.
What are you, when you're doing this Google Meet, what are you seeing the Google Meet in? Are you on a Chromebook, a computer? What are you on?
Yeah, I'm on a Chromebook.
Okay, good. With your Chromebook today, were you able to see me coding, or was it too garbly?
I was able to see you coding pretty clearly. It might be just a little bit small, but students can also pin your current screen so it shows up bigger.
Okay. We should give them that tip.
Yeah.
Yeah. And yeah, I couldn't make the console bigger. I could make the code bigger. So the code hopefully was clear. It's just not like being in the classroom where, it's right up on the screen. But okay. Well, thank you, Connor.
Yep.
You have an easy day, don't you?
Yeah. I mean, technically I'm supposed to have driver's ed, but it's like the in-person part of it. So it's kind of hard to do that online.
Yeah, for sure. Wow. Okay. Well, crazy times.
Yep.
See you later, Connor.
Yep. Have a good day.